What's up, guys? Welcome back to the GU Patrol build. At this stage, pretty much the rebuild. So after the incident we had with the piston, we got this all down to the machine shop and we sort of said, hey, look, you know, we sort of need this done urgently. And they sort of pulled it out of the hat for us and got it done in a little over a week. So we've got it all back here. We're pretty much ready to start rebuilding. But since we signed off the last video, having a very close inspection of everything that we pulled out of this thing, there's a few new developments that we sort of are getting a little bit more of a better idea of what the hell happened to this thing, what led to it going to this point. But what they had to do was just sleeve the one pot that that piston melted just because of the heat on the alloy. So this one's been re-sleeved, and then it's all just been honed, new cam bearings, you know, basically all the works, and it's going to be getting all new bearings, new rings, and obviously new main bolts and rod bolts, because those in LSs are torque to yield. And you can reuse them. We have reused them in our own engines before, but for customers' engines, we just don't bother. It's not worth it. We just put all new hardware in them. So basically be a completely fresh engine when the owner gets it back. Anyway, so what we actually found when we had a really close inspection, pulling this all apart, number one, the one that was torched, at closer inspection actually has a bent rod. So the rod's not straight.
You see how that's bent? I don't know if it'll show up on camera, but it is definitely a little bit bendy. It's not too bad that way. That way, definitely.
Yep. You know, no amount of knock will induce enough cylinder pressure to bend a rod. So that is, well, not one of these rods at the very least, but that is evidence that it's something else has happened at some point. Like you guys probably remember when we did the stock bottom end on this thing, all of the intake valves were bent, all of the pistons had witness marks where all of the intake valves had kissed the pistons.
So they're all like that.
So we had to get all new intake valves for this engine. So that was sort of the first weird thing about it. But unfortunately, the owner actually got scammed out of a 6-litre before he bought the LS1. So he was already down a fair bit of money, and it was pretty low Ks. So he decided that, you know, him and us together decided basically we'd just leave it as a stock bottom end, we wouldn't bother pulling it down. So it just is what it is. That's the risk with running stock bottom ends. But basically something happened to bend that rod prior. It must have had water or fuel. You know, generally it's a hydrolock which will bend a rod, because as we know, fluid doesn't compress like air, and generally if you get a pot full of fluid and it can't go anywhere, you end up bending a rod. So that's likely what happened, and Rex has found evidence on some of the rings off some of the other pistons that it has had water in it.
Well, that's number one, but it's, oops, sorry about that. That's number one, which is obviously that's all just burnt from where it let go. There was a couple of marks somewhere, but like that's the top ring out of number 2, and like all of that is all corrosion from water. And then you've got obviously number 1's the one that let go bad, has a bent rod. Number 5, it had just started to go, but I can't see any evidence of a bent rod there. Then yeah, we've got all eight pistons had touched intake valves, but these are all standard GM bearings. They appear to be the standard rings. So I'm trying to figure out what fucking life this motor led, where
all
with
of the
stock
can
that came out of it, like how did it
kiss all the intake valves? That was already a weird thing. We were already scratching our heads about that one.
And you can see like the marks in them, like they are covered over. So like
it has been running.
It was running after they touched. So, but either way, my conclusion at this point into this failure is this bent rod, which just turning the motor over and looking at it, like that's, if that was in a motor, you can't really see that. The only way we could have seen that would have been to measure each piston
deck height
at the top of its deck, which is you know, maybe we should have done that, but.
It's one of those things, like there are probably a lot of checks we should have done. Like I said at the last episode, we probably should have done a leak down on the engine before we went and pulled the heads off it to start with. You know, we probably could have checked all the deck heights, but you got to draw the line somewhere. It's a stock bottom end.
Valves would have said that the leak down was shit, so that wouldn't have told us anything about these. But anyway, my conclusion is that as I knew when I was tuning this, it just was generating knock when it shouldn't have been. My conclusion is that with this bent rod, that's obviously going to shorten the deck height, which has opened up our quench area. And it was just this. I don't think any of the others were particularly knocking. I reckon it kept picking up this particular cylinder that was getting bad knock because of the reduced quench height.
Yeah. So because LSs are a two valve engine, it's very important to have that quench to get an even burn. And once you start reducing the quench, you start to get, you know, pockets of uneven air and fuel, which obviously leads to knock or detonation. So that's a pretty common thing, or well-known thing, particularly with two valve engines with an offset plug, is how important the quench is.
So if you don't have soft chamber heads, the quench height's very important.
Yeah.
So that is my suspicion as to what led to this particular failure. When we do get it back together, I'm still going to do our back pressure
tests,
and
yeah.
that snorkel, the intake vacuum test. I feel like there's probably a couple of things that were not helping, but
yep.
I think that's my suspicion at the moment. That was probably the main.
So yeah, without that quench height coupled with that terrible fuel, it was just a bad combination of things for that pot to just basically detonate. And anyway, it is what it is. Like I said, it's sort of the risk you run with stock bottom end. It's still, you know, something we probably should have picked up earlier, but like we talked about, we were sort of trying to get this thing ready for King of the Strip and under the pump and pretty stressed out, and it was basically just at the timing and boost that this thing was seeing, it definitely shouldn't have been knocking. But anyway, it is what it is. All we can do is fix it and rebuild it. But so yeah, that pot's been re-sleeved. We've got a new piston and rod to go in there. We've got a few new pistons and rods, and we'll get this thing all back together and back in the patrol and back in action. And like Rex said, we'll continue on with the tests that we were doing prior to the let go. Get some more data together, but I've got a feeling that this thing after a rebuild is gonna be sweet. So,
and after the lessons we've learnt recently, this one, that other motor that we rebuilt for our mate from Kingaroy, I reckon no more of this
stock bottom end stuff.
Well, if it's stock bottom end, that's fine, but we're rebuilding it. We're checking everything. There's no more
guess.
No more just run it.
Yeah.
If a customer wants to put it in themselves and run it, that's no worries, but we're not going to take responsibility for if something like this happens. But this is a pretty shit situation for us where, like, obviously the motor had a problem, but we had all agreed not to rebuild the bottom end, but because we did the motor and we did the build and I was tuning it, we have to wear it still.
Yeah.
So
yeah, that's it.
Don't want to end up in this situation.
All this is an analysis of what actually went wrong. At the end of the day, we still gotta wear this one. But anyway, we'll get it sorted. So the other thing is, if any of you's watched our King of the Strip prep, so that same week after this thing happened, we had an issue with the dyno computer. Yeah, anyway, we that was the week leading up to King of the Strip, and we finally got the cruiser on the dyno that Friday. And on that, it would have been the same batch of fuel, because we know what days the servo gets loads of fuel. So it would have been the same batch, and the cruiser was doing the same thing, just on boost and timing, where it was never a problem before. It was just knocking its head off. So
nowhere near as bad as this one was, but it was still showing.
Yeah, lots of knocks. So that sort of proves the fact that it was really a terrible batch of fuel. We've had a few cars since, and the fuel's not been bad. So we think it must have just been one batch, like we talked about with all the rain we had recently. But anyway, we'll get this back together, get it back in the car, and get it back happening really, and then get it back to the owner. So Rex has just been cleaning up these pistons, and like you can see, after it's cleaned up, all the carbon's gone. Like, that's a pretty serious witness mark. That valve didn't just kiss that piston. That's a pretty solid hit.
And some of them are worse than others.
Yeah, it's very strange. Again, just weird stock bottom end stuff. Anyway, we'll try and sort of get rid of the sharp edges on those, because obviously the sharp edges on those aren't going to be helping either. So you can see that one's not so bad. And then yeah, like this one, that's pretty horrific. That's pretty horrendous, that is. But anyway. Rightio, rings are all gapped. Final clean of the block's all been done. Rex is at the moment just starting on the bearing clearances. Measuring some clearances. We've got some fresh rod bolts to go in. I already went through that, I think. Rod bolts, new rods and mains, because they talk to yield. So yeah, should go together. It is nice being able to control the entire engine from start to finish. Get to actually gap the rings properly and everything else. So it'll be a bloody grouse little engine when it's finished.
I don't know if you showed him, but I did think that was before.
Oh yeah, went over and smoothed them out a bit.
Yeah, just
took the sharp edges off them.
Yeah, so it's left a little bit of just a little bit of a groove on it, but it's better
Still
than
better
having
than sharp edge.
Better than having the sharp edges. Even
So-
there was a couple around like the outsides. There's where something's touched them, and there was some little sharp edges there. I took them off too. Like went around each piston.
Yep.
And checked the top of each one to make sure that there was no sharp edges around here too.
So the issue with sharp edges inside the combustion chamber is that at those sharp points you get a lot more heat than the rest of the combustion chamber, and if it gets enough heat in it, it can actually auto ignite the fuel and air mixture in the combustion chamber instead.
Like a little glow plug.
Yeah, basically. Yeah. So yeah, it'll auto ignite, which induces a pre-ignition, which can obviously be very, very bad. That's very not good. Righto, boys and girls, working overtime to get this thing back together. It's all coming together quite well. All the deck lights have been checked now with all the replaced pistons and everything else. The deck lights only range around 4 thou, which is, you know, stuff all. So everything looking good at this point, except for this, which we found. So we've got here a couple of broken valve springs, which is pretty interesting. So because we're in such a rush, when we got everything down to our machinist after we found that those intake valves were leaking, we left the heads together, took them all down to the machine shop, and basically just gave them to them complete. It was just like, you know, can you please do the intake valves because they're not sealing properly. And when we went to pick them up, he sort of pointed out that he found one broken spring. So one of them he found, and the other one Rex found just before. But you can see both of them have broken the inner spring. And if you look closely, it's probably going to be hard to see on camera, but there is, you can see on the face there of the brake.
This one might be easier because you can see straight at the side of it.
There's a shiny spot. I don't think the camera's really picking them up.
Yeah, probably not.
But there's a shiny spot, like there was obvious imperfection in the manufacturing, so it definitely seems to be a manufacturing fault which has caused a weak point in both springs, and they have obviously broken. So we've never had an issue with these springs before. We do know of other engine builders that don't like them, and that have had lots of issues previously, but this is the first time we've ever had an issue with them. And it's not particularly an aggressive cam. It's not really working these springs that hard. So we'll have a chat to the supplier about the fact that it's probably just a bad batch, we think. But it's a little bit of a concern. It's the sort of thing where, because of the make of the spring, you can't see that sort of defect just from looking at it, really. I don't think you'd be able to see it. And even while that spring was together, I'm not even sure that you'd pick that up on a spring test. So it's one of those things where I don't know if there's any way you could really detect a fault like that prior to it letting go. But this is a really good example of why we really like to use double springs, because, you know, even if you break an inner or an outer, as long as the other one remains intact, you can generally pick it up or figure it out or fault find it before something really bad happens. Whereas if you've only got a single spring, a beehive or something, and something like this happens, well then chances are you're going to smash a valve into a piston and it's going to be game over. So that's a good example of why we like doubles, but we'll have to try and... We're just going to use a whole nother batch of springs, a whole nother box. We've got some more in stock. So we just use we can replace all the springs and everything. Use a whole new set, just in case this was just a batch issue. And we'll get onto the supplier about that. But anyway, it'll get sorted again. So heads are ready to go back together. They can go back on, and then it's just about time to get this thing in the car again.
But it's a shame, we don't know. So we know that one of those broken springs they found on number 5. We're not sure which valve. The other one, we don't know.
Well, we don't know it was number 5 either. He just said it was the same bank, it was further back.
Yeah.
He didn't say it was number 5.
Yeah, okay. We suspect it was
We suspect it was number 5, because it was the other. Number 5 also had a cracked ring land in the piston, so we suspect that the sad valve spring that was already broken that the machinist found was probably on number 5, and it may have had something to do with the cracked ring land on number 5.
Yeah, well, now I'm wondering if the other broken spring might have been on number 1. The problem was, it was hard to spot because it was only because I started looking for it, because whilst that one came out obviously in 2 pieces, that was pretty obvious. This one had just broken and was still sitting in the top of the spring. It was only because I decided, like, because one was broken obviously, I started inspecting all of them and found that it was jammed in there and I got it out. But when you pulled it apart, if you weren't looking for it, it would have been easy to miss. But now I'm wondering if it might have been on number 1.
Compounding error issue?
Yeah, I'm just trying to work out how a broken valve spring could induce knock. The only thought that's really coming to mind is if they're on the exhaust valves and it's upset the exhaust valve and it's not sealing, and that's leading to a contaminated charge in the cylinder. That definitely induce knock. And then number one, obviously, combined with the fact that the rod was bent and the compression height, our quench height was no longer ideal. Number one was the first to fail, but number 5 was obviously upset as well. But the others all seemed fine. They showed no evidence of detonation or no evidence of it being unhappy at all. So, I don't really believe in coincidences of that nature. We've got 2 broken springs and 2 broken upset cylinders, so it's a bit of a stretch. It's a shame, like you said, that we're in such a rush, because normally, like, if I'd pull the heads apart as we pull stuff apart, we lay it all out, we would have known exactly where they came from, and that might have led to some more definitive, sure answers. But
you will notice that us and a lot of other engine builders do that. When you start pulling stuff apart out of an engine, you all lay it out exactly where it came from. That way, when you do find stuff, you can go back through everything and you know exactly where everything was, and everything starts to paint a nice little pretty picture of exactly what happened.
Pretty picture is not the word I use for this. But
righto, boys and girls.
She is going together.
Just about done. Just about ready to start smashing it back into the car. So another thing that we actually found, or Rex found just earlier today with this thing, he went to put the rockers on again, on all the same rocker gear as before. We've got our rockers with our CHG kit through them and the rocker posts and everything. He went to put them on, and as you tighten them down, generally they'll locate on the post and they'll be quite, you shouldn't be able to move them diagonally very much, but a few of them he tightened down, they didn't quite straighten up and they were a little bit average. They weren't doing what they should have done, basically. And what we found was that the rocker rails are actually quite worn. You can see some of the tops there. You see how that second one along's quite sharp, and then the next one, the corners are rounded off. And you can sort of see that they've sort of got a fair bit of wear on the rocker posts, a lot more than we normally see. Anyway, it's just another really weird thing with this engine that sort of makes you worry about what sort of life it had before. Yeah, not that any of it matters now, it's all been rebuilt, but brand new rocker post this time around as well. And yeah, that could have had something to do with our spring issue, who knows. It's yeah, anyway, it's all going to be fresh this time around, so honestly, probably a bit of a blessing in disguise for this little thing. Ended up getting rebuilt. Still a crappy situation, either way, but as we said, that's the risk with stock bottom end stuff. It's the game you play. But anyway, at least it's all fresh now, and we know it's all good now, so.
Anyway guys, we'll get these all torqued up.
We'll get it back in the hole, and we'll get this thing back on the dyno, and do some more fault finding with the rest of the setup. But what we've seen in this engine, everything sort of makes sense. Not so inclined to think that there is much of a problem with the rest of the setup after obviously seeing the sort of condition that of the engine we were working with. So
you can see there with the new rocker rail, those things, the rockers are dead straight up and down, perpendicular to the rail, and you can't move them at all. Whereas with the old ones, we noticed a few of them, once tightened down, were still a bit. They hadn't sort of located how they should. So yeah, weird thing to find. But anyway. What do you do except for replace the rocker rail, make it brand new?
Still, a lot of testing to be done either way. We won't sleep at night until we test it all and do all of our fault finding and make sure everything's sweet. So it's all going to happen anyway, but we'll do that on the next episode. Thanks for watching. As always, guys, we'll see you on the next one. Peace out. See you. Bye.